Hello, so today we are going to do problems from weekly contest 347. The second problem is difference of number of distinct values on a diagonals. Okay, so basically here we have a grid, m by n grid, and we want to find this answer matrix that is also m by n, where the values of this answer are as follows. For every cell RC in matrix answer, we calculated using this. So it's basically the absolute difference between the top left of RC and the bottom right of RC. But what are those two matrices? Well, this one top left is just the number of distinct values in the top diagonal of the cell, of that cell, and the bottom right is the number of distinct value in the bottom right of the diagonal. So what do we mean by that? Well, what it means is, for example, for this one here, the top left numbers are just this one. For the bottom right is just this one, right? Because this is the diagonal. Let's take another different example. So what about this one? What are the top left diagonal? Well, there is no top left diagonal, so nothing. But there is this bottom right diagonal. It's just this one. Okay. If the list, let's say, if the matrix has more values, let's say 4, 5, maybe it's 4 by 4, 6, 7, and some other values like this, then the bottom right will also have this 5 here. Okay. So that's sort of the idea of the top left and the bottom right. Let's take another example just for top left. So for example, this 2 here, or let's put it here. So this 2 here has this element as the top left only and has no bottom right. Okay. So that's the idea of these two values that we'll need to calculate. And so we basically want to return the answer where for every cell we calculate the difference between both. And these, remember, are just the number of distinct values. So this should be pretty simple, since also the constraint are not too big. We have up to 50. So, well, we can actually tackle it exactly as we are asked, right? What is the top left? Well, the top left is just of each element. You can see here, even like if we take a look, for example, here, what is the top left here? Well, the top left is just the previous row in the previous column, right? So for this one, it's r minus 1 and c minus 1. So if these are the indices 0, 1, 2, 0, 1, 2. So what are so this one is 1, 1. Its top left is 1 minus 1 and then 1 minus 1. So 0, 0. And the bottom right is just row plus 1 and column plus 1. That's sort of just the definition. For example, this here, the bottom right is just this one, which is basically because this is 1 and this is 0. So it's just 0 plus 1. So it's row 1. And then 1 plus 1, it's column 2. And so that's why it's here, right? So it's pretty straightforward to find the top left of an element. So it's pretty straightforward to find the top left of an element. So basically for RC, the top left is you keep doing r minus 1, c minus 1 until you go out of bound, you stop, right? And so you keep doing it, r minus 2, c minus 2. So each time you subtract 1. And then for this is the top left portion of the diagonal. For the bottom right portion, you just add 1, right? So you just add 1. So it's going to be r plus 1, c plus 1. And then you again increment by 1 again. And each time you just add 1 until you go out of bounds, right? Until we reach the end of the diagonal, okay? And so that's simple. Let's just apply it. So first what we need is the number of rows and number of columns. So this would be, let's just make this shorter to write with m here. So this is the number of rows and this is the number of columns we need. And then we need our answer array that will return. We'll just initialize it first to 0. So this is in the range of columns. And then we need similarly for the range of rows. Okay. And now we'll just go through each cell and just calculate the exact value that we have here for it, right? So that would be like this. Okay. And so this would be just going through each one of them. So here would be C. And then we just need remember what we need for the top left is the number of distinct values. And so how do we get this? Well, we could just use a set for the top left elements for each cell, and then just get the length at the end, right? And so we'll use a set for the top left and the bottom right. In the bottom right, yep. So this needs to be the bottom right. And then what we will do is we will just start calculating, right? So for the first we'll do for the top left. So for the top left here starts out -1, right? And then we'll keep going while we are in bounds. And so in bounds we could just say r and okay. While we are in bounds, we'll just keep subtracting 1. But we will also add it to the set so that we can get the number of distinct elements. So what do we need to add? The value itself, right? So n r and c, okay? And then now we do the bottom right. We should be pretty similar, except we will add 1 instead of subtract 1. And so that would be +1 here, +1 here, right? And this will need to be bottom right. Let's just match it. Bottom right set. And now at the end, what should be the answer position value is just the difference, just this exact value. And so what is this? Well, this is just, let's just convert it. So this should be the absolute value, and this should be the top left set. This should be just the length of the top left set. So it's length. And this should be the length of the top bottom right set for this position, okay? And that should be it. And then at the end we can just return answer, okay? And yeah, so let's run this. Looks like there is syntax error here. Looks like there is a small problem. Let's see. Sorry, this should be +1, right? Because we initially start at +1. Okay, let's submit. And that passes, okay? Now I want to show you a couple of improvements here. First, this is redundant, right? We do the same thing. The only thing that changes is here we do +1 and here we do -1, right? And so let's sort of create a function, right? Whenever there is, we need to do we need to make something common, we can just create a function. Let's call it diagonal, right? So what do we need? We need the starting row and the starting column. So let's call them RC. And we need the step that we add. So for this one, we can pass -1, and for this one, we can pass 1. Okay, so this is what we'll do here. And what do we need to do? Well, each time we just want to, first we'd want to do the initialization. So it's going to be something like this. And then we want to do while inbound. What is this +1 here? This needs to be plus the step, right? So that it's -1 in this case and +1 in this case, right? And so here we'll just add the step. So let's call it plus step. But how do we handle this case here? Because these are different set. Well, we could either decide to pass the set and then return it at the end, or create it and then return it at the end, right? So we can do like this. So maybe call it diagonal set, like this, and then that is just what we use here. And then at the end, just return that diagonal set. And now it should be easy to just remove all of this stuff and just say the top left set is going to be the diagonal, right? And then the step is -1. And then the bottom right, it's similarly, except here we need to add 1, but we need the length. The length, we get it already here, so we should be fine. So let's just try this. So sorry, this should be set, and let's submit, and this passes, right? So we got rid of the duplication there. Now another thing actually we can do here is also, instead of adding here, we can just make this use a list comprehension and just return it. And so that what that would mean basically is the first step we'll need to do is just move this here, okay? And now it should be easy. Instead of doing this, we could just return it as a list comprehension. So it's going to be like this. and this is needs to be first for each column, right? And then we'll need to do this for each row, and just using a list comprehension. If this is harder for you to understand, no problem, but you can skip it, but I want to show you how you can use list comprehension for this. So we have 2 for loops here. Let's just get rid of one, and this works fine. Okay. Yeah, I think that should be it. Now you could use even like we can remove this actually. You can use a slight improvements if you want, which is instead of passing a set and creating it, you could just use yield in Python, which will just return it each time, return the value. Okay, and if we do it like this, then here you could just have the diagonal converted to a set because it will return you the elements, and then just do it like this. Okay, this is also totally valid. Application of yield here. Yeah, but I would argue that the previous solution was more readable. Yeah, but that's pretty much it. You can see how we sort of shortened it and made it more general. Yeah, that's it. Please like and subscribe, and see you on the next one. Bye.